Okay, we have a nice question here. Let us digest it also. We are having still over theta above the horizontal. So here the particle is projected with a speed of 10 root two meters per second, as you can see. From the top of the cliff, I have 50 meters high. 50 meters high. I'm drawing already the sketch. I drew the sketch already. The particle hits the sea at a distance 100 meters. It hits the sea, so meaning it will be there through a point of projection. Show that there are two possible directions of projection which are perpendicular. In simple terms, normally they ask you for this. In simple terms, they are asking for the angle of projection, the direction. It's the same as the angle of projection. So recall from these two formula, x equal to this and y equal to this. If you make the subject and substitute this is the, I think you remember that equation in the first lesson. So now, this is the equation. Now, here they're telling us that the distance, if it is covered from here up to here, the angle of projection. So, here is that we are going to use our distance, but it says below the point of projection, which is 10 meters. So I mean 50 meters, so it's going to be negative. But now why are we using t? We are removing t because here they don't be there. We don't have anything like time. So it's that from here, our y is going to be negative 50 meters. So putting it there, we have now negative 50 equaling to x, the horizontal distance. By the time it is here, we have covered 100. So there our x is going to be 100 meters. So 100 tan theta minus d into 100 squared into 1 plus tan squared theta, the whole over 2. Then when you square u, when you square here, remember our u. Okay, our u is equal to 10 root 2d. When you square it, you shall get 100 to d. So we shall get there in 2. Okay, let me do it at once. 100 times 2g. When you square u. Because our u is 10 root 2d. When you square u, you shall get 100 to d, which is the case there. Now this d is going to vanish there, and then 100 is going to go with 1. Then by this 2 here we shall be having, and this we shall be having now 25. 4 goes there 25 times. And so what do we have now? We have now negative 50 equaling to 100 tan theta, then minus 25, we open brackets, okay, 1 plus tan squared theta. We can divide this by 25, negative 25. So divide that by negative 25, we have here 2 equaling to negative 4 tan theta, then plus 1 plus tan squared theta. Divide through by negative 25. Divided through by negative 25. So you can make this quadratic that we are going to be having now. What are we having? We have tan squared theta, then minus 4 tan theta. When I bring this one this side, I'll be having minus, okay, will be equal to 1 when I take this the other side. So here, you can easily complete squares. So if you complete squares, you get a half of this. So this will be tan theta, a half of this, then squared. Then from here, we shall subtract off half of this one here, which will be this squared. Then you shall subtract it on both sides. So if you do this, the whole process has been completed. So now I'm going to say this will be equal to now a 1. So when I do this now, you see I'll be having tan theta minus 2 squared equal to 2. This is 4, take it aside. 5. Getting the square root, my turn. So now, here I'm having two possible roots. Minus 2 getting the square root will be plus or minus root 5. When I take to the other side, sorry, this is theta. My tan theta will be 2 plus or minus root 5. This shows that now there are two possible directions. Hence, two possible angles. Now, they want us to show that they are perpendicular. So, I'm going to say, assuming the first one, theta 1, is going to be the positive 1 plus root 5, or theta 2 will be 2 minus root 5. So after doing this, now what happens? If they are perpendicular, if they are perpendicular, then, meaning when we multiply them, we should get a negative 1. Then, tan theta 1 times tan theta 2 should be equal to 2. Then, their product is negative 1. So let us see. So this is going to be 2 plus root 5 into now 2 minus root 5. And see I set difference of the squares, then minus root 5 squared, which will be 4 minus 5, which shows that now our tan theta 1 times tan theta 2 is leaving us negative 1, hence perpendicular. Perpendicular. And so that will be our part A. The whole of part A is there. Then when we come to part B, they are telling us that determine the time taken for the point of projection in each case. Now they want us to get the theta 1 and the theta 2. So from my tan theta 1 equaling to 2 plus root 5, means that my theta 1 is going to be, to get the angle there, then tan theta 2 will be equaling to 2 minus root 5. So here, my theta 2 will be, so here you get 2 plus root 5. So here I'm getting 76.72 degrees. Yet here I'm getting minus 13.28. But what does this negative show? It shows that it's below. Negative means it's below the horizontal. That's the meaning, the interpretation there. Now, if they want us to get the time taken in each case, it means that they are asking, we have the distance from our x equaling to the initial u cos theta t. Now, if I call this theta 1, then I call this one t1. So now my distance, of course, the distance covered is 100. So I have now 100 equaling to u, which is 10 root 2. Our is 9.8. Okay, then cos of theta 1, which is 76.72 into t1. So our t1 will be now, when we get this divided by that, we have root 19.6 times 10 cos 76.72 2. So here I'm getting 9.8331 seconds. So the time for the projection from here, if we take this as our angle, it's going to be that. Then for this one, you see that here, our x will be equal to u cos theta 2 t2. So our t2 will be x over u cos theta 2. Our t2 will be 100 over 10 root 2 into 9.8, the g. Then cos of 13, we take it as a positive, not a negative. So our t here will be so this will be 2.3208 seconds. So in simple terms, we see that when we project it below the horizontal, it will reach the distance over 100 faster than when we project it above the horizontal. So that's the simple interpretation we can have there. And so that's determining the time taken for the point of projection in each case. When theta is this, this is the time, and when theta is this one means below the horizontal. It will take it that time to reach this. Why? Because of course this one is hanging out of, but if it is below, it will just come. This one is hanging out of time. Okay, so that's why I had that. I wish you well.